everyone. This lesson is going to be about the amplitude for sine of x and cosine of x. So we're going to start with looking at just the regular y equals sine x that we've already talked about from 0 to 2 pi. Amplitude, you may know this word in English, is very similar to the word height. So if you think about amplitude, we're going to think about the height of this function. And the way we define amplitude is it's from the center of the function, so that would be the x-axis here, to the peaks, whether they're high or low peaks. So this right here would be the amplitude at distance, and also this distance right here would be the amplitude. And it's defined as the maximum distance, so it's not here or here or here. It's from peak to the middle line. So if you think about this distance for y equals sine of x, if down here is 0 and up here is at 1, the amplitude for y equals sine x is 1. And same thing here. The distance between 0 and -1 is 1. Notice how this is distance, which means that amplitude is always positive. That's an important point when we get to what's going to happen with negative numbers. And you'll see that in a little bit. So amplitude is always positive. Now if we look at our function here, where we see a 1 is right in front. This is really y equals 1 sine x. And so we're going to look for the amplitude as the coefficient of the function. Cosine, I'm not going to go through it, but if we were to draw the cosine function, it also has an amplitude of 1. So y equals cosine of x also has an amplitude equal to 1, because if you sketch it, here this distance is 1 and so is this distance. So let's see one that's not 1. Y equals 2 sine of x. So what's going to happen here is that this number in front tells you the amplitude. So I know that the amplitude for this function 2 sine x is equal to 2, which means that the distance from the center, the x-axis, to the peaks should be 2 instead of 1. So I'm going to go ahead and graph this. We still have the same markings, pi over 2, pi, 3 pi over 2, and 2 pi. Normally sine of x goes up to 1. But because our amplitude is now going to be 2, this distance needs to be 2. So now, instead of going up to 1, our function will go up to 2. And it'll also go down to -2. So sine of x will still start at 0, 0. But instead of going up to 1, we're going to go up to 2 because our height, our amplitude needs to be 2. Back down to 0. Down to -2, and then back to 0. So increased amplitude means that this distance right here has increased. That is 2. This distance here is also 2, from 0 to the -2. So that's all you're going to have to do to graph these functions, is change your maximum and minimum from 1 to whatever the amplitude is. So let's do a cosine one. If I were to do y equals 3 cosine of x. Again, this number out front governs the amplitude, so the amplitude is going to be equal to 3. Same markings, pi over 2, pi, 3 pi over 2, and 2 pi. And on the y-axis, you have 1, 2, 3, -1, -2, and -3. The reason we're doing this is because instead of starting at 1, like cosine normally does, we're going to start up at 3. Down to 0, -3, 0, and +3. So here you can see the distance from the x-axis to these peaks that distance is 3, which is what the amplitude represents. That distance right there is also 3. You do not have to draw this part, I'm just showing you what the amplitude represents. You're going to see 1 or 2 problems on your homework that have a negative in front. So let's go back to y equals negative 3 cosine of x. So all I've done is change this 3 to a negative 3. The amplitude will still be 3. So like I said, amplitude is always positive. But if you think back to what we did last semester, the negative in front flipped the function. So if you remember negative x squared, for example, that made it an upside down parabola. So if you have a negative function, you're just going to flip everything upside down. So instead of starting up at 3, so here's 3 cosine x, we went up to 3, but instead of being positive, we're going to start, oops, wrong way, we're going to start down at negative 3. Then we're going to go to 0, then to 3, back down to 0, and down to negative 3. So what you're going to see is an upside down cosine graph. So here's y equals 3 cosine x. Here's y equals negative 3 cosine x. They're just upside down. Some of you at this point have got this, but I'm going to do one with sine of x that's negative, just so you can see that. So let's do y equals negative 2 sine of x. Again, we're going to have an amplitude of 2, which means our max and min will be 2 and negative 2. And sine starts at 0, 0. So it's still going to start at 0, 0. There's no reflecting going on yet. Normally, with an amplitude of 2, we would be going up to 2. But because this is negative, we're going to go down to negative 2. Back to 0, up to 2, back to 0. So notice how the sine curve is upside down. What used to be here is now upside down. What used to be down here is now right side up. So the negative sign just flips it over the x-axis. And you have 4 problems to do for homework. Those are on RenWeb, and I will see you on Monday. Have a great weekend.